Hello, I'm Alex Lebehusen, and I'm a principal software engineer here at LifeOmic working on the Precision OCR product. LifeOmic has been serving as a data platform for healthcare providers and research institutions for the past 4.5 years. Now, during this time, working with our customers, we noticed that they were often running into issues revolving around medical documents. Medical documents are just a pain to work with. They come in a multitude of file formats, from images, PDFs, faxes, scans, even just doctor's notes. They can also come in huge files, so hundreds if not thousands of pages long. And when working with these huge files, you don't even have search or copy and paste because a scan or a fax is essentially just an image file. Not only that, but when working with these files, security is absolutely paramount. You have to be sure that you're handling, storing, and sending these in the best and most secure way possible. But we deal with all these pain points because medical documents tend to have the richest and most important aspects of a patient's history for their medical charts. Now, we here at LifeOmic noticed these issues and decided to build a product called Precision OCR to help address some of these concerns. So I'm going to demo for you a few key features we built into the Precision OCR product. Here is the OCR dashboard. The dashboard provides a listing of files within your projects, but also a way to upload new documents to your project. Simply drag and drop a new file. Here I'm uploading a sample patient history. And upon uploading the file, processing will begin. Aside from providing UIs to upload files, we also provide APIs and CLIs to automate bulk uploading of files. So whether you have a dozen documents or literally thousands of documents, the platform will scale to handle any workload. Here's that patient history document we just uploaded. Oftentimes, whenever one organization requests the patient history from another organization, such as a patient referral, that sending organization will compile all that patient's documents into one big file and send that over via fax or email. Now, as the receiving organization, that format isn't very helpful. Ultimately, what I'd like is all the original documents sectioned out. So whenever we developed Precision OCR, we added this concept of organizing a document. Here we can go over to the Organize view. And what this is mimicking is laying out that huge document over a table. And there we can make stacks of each section and add labels and dates to them. So here we can go through and select pages. We get a suggestion of the date that's labeled in green. And here you can see it's suggesting that the date and time collected is the date. That seems correct. We can go ahead and click that suggestion and assign a type. This looks like a lab report, so we'll do that. We can click submit, and we created a nice stack of 2 pages of a lab report from November 28th, 2016. We can go through and do that with the rest of the pages as well. So here's a consult note. It's suggesting the right date, and we can label it accordingly. We can go through the rest of the document doing the same. As you go through and do this more and more in a project, that data is leveraged by machine learning models specific to your project and will make the suggestions more efficient and better in the future. Once this is complete, we can go back to the document view, open the details, and you'll see we have a nice table of contents laying out all the sections. We can easily jump to the consult note, and we see that table of contents is now viewing the consult notes section. This ultimately makes that whole process of sectioning out huge documents much more efficient. This is that same patient record we uploaded earlier. As with most patient records, it's very informationally dense, and it's just hard to make sense of all the data. So when developing Precision OCR, we added a lot of tools and features to make this job easier. So let's say hypothetically, this patient was diagnosed with thyroid cancer back in 2016. And we want to find any bits of data within this document that might help us make sense of that diagnosis. So one of the key features we added, very simply, was a search bar. We can type in thyroid, and we can pull up a lot of lab reports that have relevant readings for thyroid cancer. But maybe most interestingly, is we can search handwritten doctor's notes. And we can see that the doctor wrote some notes about his thyroid here. Now, before Precision OCR, this was a very opaque layer of data. If we wanted to search handwritten doctor's notes for a mention of thyroid, we probably would have had to manually go through and search those documents. Now it's as simple as a search bar. We also annotate dates when you upload a document. So here I can toggle document dates, and I get all the document dates highlighted. These can be very directly written dates, such as November 28th, 2016 here, but we also do relative dates, such as today, or last Friday, or next May. And with all that information, we can compile a patient timeline automatically. And since we're really interested in 2016 when they were diagnosed with cancer, we can look through this timeline and pull up any document mentioning a date within 2016. We also do PHI redaction. So if I toggle this on, you can see bits of the document that were automatically redacted of PHI. And we can also unredact sections of the document we don't think should be redacted, or redact other bits of the document we think should. Once it's at a redaction level we deem appropriate, we can download a redacted version of this copy and share it externally. Those are just a few of the key features we added, but there are many, many more. Being able to make sense of a medical document is great, but the gold standard of medical data is digitized, interoperable, encoded medical data. And Precision OCR helps with that. So here we have that same document, and let's say we want to digitize and code some medical data from this document. Precision OCR, as part of the ingestion, will suggest bits of data. So here I highlighted all the bits of data that Precision OCR believes could be coded. We can click on one of the suggestions here, and you can see that it pre-filled a form to create a medically coded piece of data. We can create that data, and now we have extracted the multiple myeloma condition. So here we highlighted bits from the document and can search through that way, but we also supply a data tables format. And here you can see all the data that it found in tabular form. We can search through this data or filter by different aspects of the data. So if we pull up albumin here, we can see where it was at in the document, and we can also extract that. We then get tables of all the extracted data as well as the source of where it came from. We can then export via our APIs and CLIs in the FHIR format, or you can download the extracted data as a CSV. One issue healthcare providers face is organizing the constant stream of faxes and documents they receive on a daily basis. One of the issues that they have is whenever you receive a document, you need to be able to associate it to the correct patient. Now, if you just have one or two documents come in, this isn't a big task, but whenever you have hundreds, this can be a full-time job. So Precision OCR provided a feature to automatically associate a subject with a document. Here in the dashboard, we have a list of documents pending subject assignment. We see we have that one document we just uploaded, and here we can click on this button to see the suggestions of the patients probably associated with this document. So here you can see it suggests John Doe because they found his date of birth, first name, last name, and medical identifier. We can see we also have another suggestion where a first name just matched. Well, we can be pretty confident that this document belongs to John Doe. We then click the Assign button, and that document is now associated with John Doe. You can also configure your project to do this automatically based off configurable criteria. So if the subject matches on first name, last name, and medical ID number, go ahead and automatically assign it to the subject. We've seen how Precision OCR can assist users in extracting medically coded data from highly unstructured documents. But what if the documents have a lot of structure to them? such as lab reports. Here we have a patient with no data in their chart, but he does have 10 LabCorp CBC with differential platelet reports. We can simply upload those, and since we've added the LabCorp with CBC differential platelets report extractor to the project, whenever these are uploaded, that report extractor will search each of these documents and then extract properly medically coded data from those reports. Now that that is completed, you can see that the patient's chart is now filled with hundreds of medically coded data points. LifeOmic offers hundreds of the most common report extractors for free in their marketplace. There's also the capability to create your own report extractors for whatever medical documents you may have.